Okay, hello everybody. Today we're going to continue our discussion in Chapter 2, Section 5, and I'm going to show you how to write an equation based on being given a graph. If you know what the parent function is, it's kind of straightforward to be able to then just write the graph based on the transformations that we discussed in the last video. So let's take a look at this one. This is example 3. It says that this, and they're showing you the graph of f of x equals x to the fourth. And so what I want you to notice about this graph, it's very similar to x squared, although it's slightly wider. It's a little bit wider. The reason why it's a little bit wider is for numbers that are less than 1, when you take a fraction that is less than 1 to a power of 4, it's actually going to get a lot smaller than if you were to square it. And then once you get numbers beyond 1, this is going to go up a lot faster because you're taking it to the fourth power versus taking it to the second power. So what we have right here is we have a graph, and we're saying, okay, the parent function of this is f of x equals x to the fourth. And what we want to determine is what is the equation of this given graph. So there's two things going on here that we need to realize. The first thing is there was a reflection. You can clearly see that this parabola, instead of opening up, is now opening down. The way we accomplish a reflection is with a -1. Well, we need to figure out whether that -1 should be inside or outside of the x to the fourth, meaning should it be negative x to the fourth or should it be negative x, the quantity, to the fourth? And if you recall this one, if you did take that negative to the fourth power, it wouldn't change that function. The negative would actually go away, and you would end up getting the exact same graph. So what we are going to go with is this one. This negative on the outside is the correct one for the reflection that you see. So we know our parent function, f of x, is x to the fourth. So g of x is, we're going to start by writing negative x to the fourth. Now, the other thing that happened with this graph is that the graph's vertex is no longer at the origin, like you see here. It is shifted up 2 marks. So now we have to think about what causes a shift up by 2. And the shift up by 2, vertical shifts, are accomplished by being outside of the function and adding and subtracting. And vertical shifts go the way you think they should go. So if it's up 2, that is going to be a plus 2. And so now what you have is the actual equation of this uh, translated function, g of x. It is g of x equals negative x to the fourth plus 2. So we're going to try another one. Here is one where same function, same parent function. Parent function is f of x equals x to the fourth. But we need to look and see what happened to this one. And so there again, you've got to kind of quantify what your transformations are first before you try to write the equation so you know what to write. So two things are happening. You can see once again, this thing went from being opening up to opening down. And so it's the same as the last one. There is going to be a negative. And that negative will be outside. So it'll be negative and then x to the fourth. Remember, I'm saying outside because the negative is not being affected by the fourth power. Only the x is being taken to the fourth power. The next thing that happened is this thing was actually shifted, but it was shifted to the right this time. So this is a little harder one because you have to remember that horizontal movements are on the inside and they are opposite of what you would think. You would think if you wanted to go to the right that you would have to add 3. But in reality, because horizontal movements are opposite, it's going to be subtracting 3. And again, we are on the inside of the function because it is moving the function horizontally. Horizontally is inside, vertically is outside. So we're moving to the right 3 and it's moving horizontally. That means we're going to have a -3 on the inside of the function. So I'm going to go ahead and adjust this just slightly. get rid of the fourth power, I'm going to go ahead and write a minus 3 here. Now, it's important to remember that that minus 3 has to be on the inside of the function. Therefore, I need to surround the x and the minus 3 with a set of parentheses. Notice I left the negative on the outside. The reason being is this was a reflection about the x-axis. We're rotating on the x-axis, so that means the negative is on the outside. Now, here's another one I want to take a look at. Now, this one, I'm not sure if you might recognize. Hopefully you do. This is actually the square root function. So this is not the same parent function as the last two. So I'm going to go ahead and write my parent function first. We usually call those f of x, and this is simply the square root of x. Now we need to, again, quantify what the transformations are before we try to write the equation. We have to know what happened to the function. So if we were to draw the picture of the base square root, it would look just like this. Okay, so there's two things that are going on here. I think the most obvious one is you can see it was shifted down. The other thing is, notice the graph completely points in the wrong direction. It was going over this way, and now the graph is going over this way. So it was also reflected. Now we need to determine what that reflection was. Was that reflection about the x? If it was about the x, it would have been flipped over. And it doesn't look to me like it was flipped over. It looks to me like it was flipped like this. It was reflected about the y-axis. So there's two things happening. There's a reflection about the y-axis, and there is a shift down. So we need to be able to now write algebraically both of those transformations. So a reflection about the y and a shift down. I'm going to start with the reflection. So I'm going to go ahead and call this g of x. And when we have a reflection about the y-axis, remember, we had a reflection about the x in the last two, and the negative was on the outside. So how the negative was on the outside because it was a reflection about the x. This is a reflection about the y. Therefore, that's going to give us a negative on the inside. So that's going to get us the reflection. Now we need to figure out what shifts this thing down. And down, vertical shifting, is when the numbers are on the outside when you're adding or subtracting. And in this case, we went down 5, and vertical movements go the way you think. So if we go down 5, it's going to be minus 5. Because it's vertical, the minus 5 is on the outside. So there's your equation of this. It's going to be g of x equals the square root of negative x, and then outside of the square root minus 5. It says, when sketching graphs of functions involving square roots, remember that you must restrict the domain to exclude negative numbers inside the radical. Now, we did talk about that in the last unit. Remember that whatever's underneath the root, no matter what, you should set that greater than or equal to 0, and then solve it so you know what the domain is. So since this says x has to be greater than or equal to negative 2, we would say negative 2 to infinity, like that, using our interval notation. All right, that's what I have for you today, guys. I hope that made sense. And as always, if you have any questions, feel free to email me. Have a great day.